When providing temporary power to a construction project, especially in areas with high fault current potential, understanding fuse protection and let-through current is essential for safety. The question raised addresses a common scenario: supplying temporary power without engineered oversight, where fault currents can reach significant levels such as 75,000 amps at the power source. The core issue is whether the let-through current, as indicated by the fuse's current limiting graph, should determine the required ampere interrupting capacity rating of downstream panels and breakers. The answer is yes. The let-through current from the fuse current limiting graph should indeed dictate the ampere interrupting capacity, or AIC, rating of the downstream panel and circuit breakers. Here's why. The available fault current at the power source establishes the maximum possible current that can flow through the temporary power system in the event of a fault. The fuse is installed as a crucial current limiting device. Its purpose is to interrupt the circuit when the current reaches a predetermined level, known as the fuse's current rating. However, before the fuse completely interrupts the circuit, it allows a certain amount of current to pass through for a very short duration. This is the let-through current. The fuse's current limiting graph provides data on this let-through current for various fault current levels. The downstream panel and circuit breakers must be able to safely withstand the maximum current they might experience during a fault. This is where the ampere interrupting capacity, or AIC, rating comes in. The AIC rating represents the maximum fault current that a panel or breaker can safely interrupt without failing catastrophically. Therefore, the AIC rating of the downstream panel and breakers must be equal to or greater than the fuse's let-through current. Consider the example provided. The available fault current at the line side of a 100 amp JGN fuse is 42,000 amps. The fuse's current limiting graph indicates a let-through current of approximately 7,000 amps. In this scenario, a panel and breakers with a 10,000 amp AIC rating are appropriate because they can safely handle the 7,000 amps let-through current. The reasoning is that the panel and breakers need to be capable of safely interrupting a fault current up to the maximum level allowed by the fuse. Using components with an inadequate AIC rating could result in equipment failure, posing a significant safety hazard. Several additional considerations are important. One is the physical location of the temporary power service. If it is located closer to the power source, the available fault current and, consequently, the potential let-through current will likely be higher. This means a higher AIC rating will be required for the downstream equipment. Therefore, it's not just about the fuse itself, but also the potential fault current at the point of connection. 2. Conductor impedance affects fault current levels. Longer cable runs or smaller conductors will increase impedance and reduce the available fault current at the downstream panel. 3. Transformer impedance affects fault current levels. If the temporary power is being fed from a transformer, the transformer's impedance will limit the available fault current. 4. Series ratings affect system design. Under specific conditions, the combination of an upstream fuse and a downstream breaker can have a series rating that is higher than the AIC rating of the downstream breaker alone. This requires careful coordination and testing to ensure proper operation. 5. NEC requirements must be followed. The National Electrical Code has specific requirements for the selection and installation of overcurrent protection devices and equipment. In conclusion, while a 10,000 amp AIC rated panel and breaker are proper in this example scenario, it's always recommended to consult with a qualified electrician to determine the appropriate ampere interrupting capacity rating for your specific temporary power system. This will ensure the system is safe and compliant with all applicable codes and regulations. The fuse let-through current is a critical factor, but a comprehensive assessment of all relevant parameters is essential for a safe and reliable temporary power installation.